My name is Scott Colton, and I work with AWS ECS on the product team. I'm a developer advocate, and I am interested in all things Linux and container runtime. So if you want to catch me later, catch me on any of the social channels, i.e. Twitter, Slack, I'm on all of them. Today we're going to look at cost visibility, auto-scaling for elasticity, optimizing compute with spot instances and Gravitron. If you don't know, Gravitron is our ARM offering. Purchase options, so saving plans and top model, and cost optimization offerings. Let's look at the cost optimization with AWS Fargate first. There are several dimensions to the overall cost, which you might think of as total cost of ownership or TOC. At the top level, you have your workloads. These are generally your business applications that you have running in containers on the platform. And the next layer is the infrastructure, compute network and storage. Then you have the platform. In this case, it's ECS. That is followed by a DevOps toolchain, which can include a variety of security, CI/CD solutions, and more. The next layer is observability, which is a key area that consists of your logging and metrics and tracing data. The last area relating to cost is the operational cost of engineering costs, which is closely related to the compute costs that can be optimized through choosing serverless compute with Fargate or Gravitron. In this talk, we're going to look at the highlighted sections, which is workloads, compute, ECS, which is your orchestrator, and operational costs. So let's have a look at a few things with ECS. So the ECS, the cluster itself, is a fully managed service. There's no middleware, there's no install and upgrade. So what that means is you never have to upgrade your cluster. The cluster just runs in the back end and we look after all that for you. The cluster itself is free. When you're looking at Fargate as the compute runtime for ECS, it's a serverless container engine, so you don't need to worry about any of the runtime. There's no container host to upgrade, so you don't have the over operational overhead of patching or any of the security concerns that come with that. Isolation and security is by design, so we look after that on the back end for you, and it's simpler and faster to auto scale than EC2. So with cost optimization strategies, there's a few things that we need to look at. We need to first know what we are spending so we can optimize it. We can then look at optimizing auto scaling. So just scale your ECS tasks out when you need them. We can then optimize compute. So look at the size and also the architecture of the CPU. And then we can have a look at different purchase options like spot instances and whatnot. So let's look at cost visibility first, because before we can optimize our costs, we have to know what we are spending and what we're spending it on. So visualizing and understanding cost is super important if you want to save money, because if you don't know where the money's going, you can't really optimize for it. So cost optimization, in essence, allows you to drop the cost of your overall cloud spend without losing quality or uptime or going against your SLAs in any of your business applications. You can identify also cost chargeback, so different teams are doing different spends. And then, of course, if you want to optimize costs, you then also want to optimize the forecast for your spend. So these are the three major buckets that you want to look at with cost optimization. You can use Cost Explorer to view charts and usage and costs. You can view data from the last 30 months and forecast how much you're likely to spend for the next 3 months. You can also use Cost Explorer to see patterns in how much you spend on your AWS resources over time. For example, you can use it to identify areas that need further inquiry and see trends that you use to understand your costs. You can also specify time ranges for the data and view time data by day or month. The metering data in the cost and usage report shows the usage across all your Amazon ECS tasks. The metering data includes CPU usage as vCPU hours and memory usage as GB hours for each task that run. How that data is presented depends on the launch type of the task. For tasks using Fargate launch type, the line item operation column shows the Fargate task, and you'll see the cost associated with that task. You can also use the Amazon ECS manage tags to identify the service or cluster that the task belongs to. You can also use Amazon Athena and QuickSight to get more advanced graphs and views. There is a blog post and guides available online to show you how to do that. One thing we can do is tag better for cost allocation and improve visibility into workloads. Tagging your ECS and AWS Fargate resources such as services, task definitions, task clusters, and container instances will enable you to better allocate costs, improve visibility into your workloads, and easily search and identify your containerized applications. This is also useful in implementing programmatic infrastructure and management actions like scaling and defining fine-grained resource level permissions without tagging. It is difficult to manage the entire infrastructure cost in a systematic manner, which is spread across different teams, products, business units, and environments. To use the tagging feature, you must opt into the new Amazon resource name, ARN, and resource identifier ID formats. For our information, see the online docs about Amazon resource names, ARNs, and IDs. Analyze your untagged resources such as task definitions, services, tasks, and clusters spread across different teams, products, and business units and environments to save costs. This potentially will uncover running resources you otherwise might have not known about. Often resources contribute to cloud waste and in result, unnecessary charges. You can use group by tags to holistic view of untagged applications as shown here. Now let's have a look at Compute Optimizer integration with AWS Fargate. Compute Optimizer integration with Fargate over-provisioned ECS tasks and CPU and memory incurs unnecessarily costs. Under-provisioning can lead to poor application performance. Compute Optimizer delivers actionable recommendations so you can optimize CPU tasks and memory for your Amazon ECS service running on Fargate. Compute Optimizer also quantifies cost impact and adopting of these recommendations so that you can prioritize and optimize efforts based on the size and saving opportunity. Compute Optimizer recommends providing container-level CPU and memory configurations as necessary when downsizing tasks to ensure compatibility between tasks and the associated container configuration. Once you get into the Compute Optimization console, click on ECS services on Fargate to see a list of your Amazon ECS services on Fargate. The list prioritizes non-optimized Amazon ECS services on Fargate that have higher concurrent performance risk and cost-saving opportunity. A very low performance risk might mean that the current instance is predicted to always provide enough capability. The higher the performance risk, the more likely you should consider the recommendations generated by Compute Optimizer. You can see recommendations, recommended CPU and memory settings, current performance risk, and estimated monthly savings for each Amazon ECS service. Now let's have a look at Amazon Autoscaling and how you can take what you've learned in the cost optimizer and use it into autoscaling. As you can see here, ECS built-in autoscaling and self-healing delivers cost efficiency. ECS can easily scale up and scale down tasks as needed by the application demand. Moreover, the task can be spread between and on-demand, Fargate on-demand and spot instances. That's great cost savings. If a task dies in ECS, it will be replaced automatically. So let's have a look at what you get by changing processor types in cost optimization. Graviton is our ARM64 processor type. So as you can see here, we're going to have a look at Graviton 2. It's 50% faster per core encryption performance compared to Generation 1, 40% better price performance over comparable current generation x86 based instances. So as you can see there, we're in this talk, we're looking at cost optimization, and you can already see straight off the bat, if you can build your application on an ARM-based CPU architecture, there could be great cost savings involved there. It's also available in 26 regions. So when you look at the changes needed to move to Gravitron, you have to look at your code, the source repo, and you can then use something like BuildX to then build a multi-architecture build and build the code in either ARM or x86, test in either, and create a deployment artifact. So as you can see, with containerization, the build process for multi-architecture doesn't really change much. It's just a flag in your build process to flag which build architecture, or if you want to build for both. Here's a customer use case where Snap has adopted Graviton 2. Snap uses, you can see, sorry, lost my train of thought there. You can see by using Graviton 2 based instances, they were able to reduce the fleet and size significantly by lowering costs compared to C5 instances. So by changing the architecture of the underlying platform of their compute resources, they've had cost savings. And as I said, the brilliance of using containers is that the build process is just flags that are changed. So let's have a look at how, now we've looked at architectures and how we could take advantage of Gravitron 2, let's have a look at how we can look at spot instances and change from on-demand to spot. Spot instances are spare EC2 capacity that's made available to customers, such as purchase options with steep discount. Very important to make a remark here, although the price of spot instances change in time, there is no way to determine the highest bid. Bidding is altogether a thing of the spot instances. Instead, the price calculation is based on long-term supply and demand trend for the instances. Spot prices based on long-term supply and demand. Prices change gradually and smoothly. Interruptions only happen when EC2 needs capacity for on-demand, no bidding. Finally, there is the only difference between on-demand and spot instances. The word spare implies something, of course, which means that EC2 needs the capacity back. Spot instances can be interrupted, with the instance receiving notice that termination will happen in 2 minutes before the fact. That is why spot instances fit into fault-tolerant or stateless workloads better, where an interrupted instance is replaced for any other reason. Spot capacity is available with little or no impact on your workloads. There are a couple of different capacity providers that customers may wish to use: EC2 and Fargate. You may be wondering, why Fargate? Surely Fargate is its own capacity provider. That is true, but at re:Invent, we also announced Fargate Spot. which allows customers to leverage similar savings in your capacity providers by using Fargate Spot, as you can use by using EC2 Spot. With EC2 Spot, customers are using unused EC2 capacity. With Fargate Spot, AWS run Fargate tasks on the same EC2 Spot fleet. With EC2 Spot, the customer can receive up to 90% discount against the on-demand prices. And with Fargate Spot, there's currently a fleet discount rate of 70% against regular Fargate pricing. With both EC2 and Spot and Fargate Spot, customers receive a 2-minute warning when they need to reclaim the EC2 instance or Fargate task. But note, with Fargate Spot, the level of disruption is always consistent, a single task per recommendation, whereas depending on how efficiently you run your Spot instances, you may suffer larger or smaller interruptions due to reclaiming of Spot instances. With EC2 Spot customers, the customers have to do some work diversifying the Spot pool to minimize the risk of interruption. But we do that automatically with Fargate Spot. ECS has a built-in feature where you can distribute capacity and on-demand and Spot pretty easily. One of the big reasons you might want to split tasks across capacity providers is being able to leverage Spot infrastructure. Services usually need to over-provision to run more tasks than you think you need to handle temporary ticks in traffic. In such scenario, some of your tasks are based on capacity, and other offerings are extra. You can run the base tasks on demand on the extra tasks on Spot. In example, using such logic, our EC2 service scales up from 9 to 24 tasks, and our weights are 2 to 1. We get 50% more tasks for only 5 to 10% more cost. If you were using Fargate Spot capacity provider, they are not supported for Windows or ARM, but that is on the roadmap. Now let's have a look at purchase options. Containers work really well with Spot and Gravitron, but also aren't mutually exclusive. Gravitron's on savings plan is great for performance workloads committed to usage. Gravitron and x86 combines on Spot is very powerful for cost optimization methods. As your cloud environments and usage scale, optimizing your costs and correctly scaling becomes essential. You can use saving plan with on-demand and Spot instances to mix your pricing models to the best match your utilization and optimization. So may you want to start asking yourself, is workload interruption tolerant? If so, then use Spot instances. If not, considering on-demand layering and saving plans to cost optimization. Let's have a look at the top model. So let's have a look at actual demand and infrastructure cost time over 12 hours. As you can see here, with ECS, we're scaling up. With EC2, we're scaling, around this. Here is the cost optimization here. You can see the difference between the lines, and that's what you're paying extra for. With AWS Fargate Serverless, as you can see, your task scale actually with the load. So there's not the difference in the graph, as you can see there, that you're paying for when you're not using it. Let's have a look at cost optimization offerings. We've got a few offerings here. Application migration and modernization. AWS preserves application migration and modernization team, as well as partner orgs, can help you support customers to achieve this faster. Offerings such as Data Lab to help customers run POCs on their migration strategies. There's architecture review workshops. Customers can request a review of their container deployment and architecture. Account teams can, along with specialists, can help them analyze their current application architecture and identify any opportunities for cost optimization. And there's also FinHack. AWS FinHack is a cloud financial management event designed to provide hands-on learning experience for technical and finance customers, audiences, with the goal of teaching them how to sustainably manage and predict AWS spend. FinHack for containers is useful for those customers already on the cloud and want to optimize their costs overall furthermore.